Hey guys, Mrs. Horn here. Today I want to talk more about erosion and how a stream, moving water, causes erosion. What are the different things about a stream make erosion happen faster or slow it down? Before we get to the notes, I want to show you this picture, and I'm going to come back to it after we do the notes, after you become an expert on it. It says that Brad recently bought some land to build his dream home on. Now, a river runs through the middle of the land, so he asked some of his friends their opinion on which side of the river should he build his house. Should he build his house over here on side A, or should he build his house over here on side B? So side A is on this outer curve of the river, and then B would be on the inner curve of the river. So let's go through some notes, and then I'm going to come back to this. All right, so how does a stream cause erosion? Well, there are some things that are factors to having moving water erode away sediment. Now, don't forget what erosion is, because weathering was breaking rocks or sediments down into smaller pieces, but erosion is moving them to a new location. The first factor is velocity. If the river or the stream is moving very quickly, then erosion will happen faster. So if you have a fast-moving stream, it's going to move sediments out of that stream a lot faster than if you had a slow trickling stream. Okay, for example, if you were whitewater rafting down a river and it was really fast and there's lots of white caps on the river, that's considered high velocity, which means erosion would be pretty significant. To compare it to if you were to, let's say, float down a river in a nice comfy inner tube, and you were just going to go slow and take your time, and it's going to be nice and relaxing, well, that velocity is a lot slower, so the erosion would be significantly less. Second factor, volume. And when I say volume, I mean volume of the stream. How much water is actually in the stream? If there's a lot of water in the stream, erosion will increase. When is there a lot of water in a stream? Well, probably today. It rained all day today, so any creeks or rivers that are in our area are probably filling up to capacity. The volume of water is increasing, and that is going to move more sediment away. The erosion is going to happen much faster. I want you to make two graphs that go with these two factors. So the blue one says velocity, and that is a direct relationship. It shows that as velocity increases, the rate of erosion will also increase. And the same with the red graph. I want you to put volume on the y-axis, and as volume increases, the rate of erosion is going to increase. Okay. The next one is gradient. Now, we've talked about gradient, but it's been a long time. We have not talked about it probably since we did maps and topographic maps, and we actually calculated gradient on a map. Well, the gradient is how steep is the stream. And if the gradient is very high, so if it's very steep, then that means the stream is going to be moving faster, and hence erosion would happen faster. So when the gradient is high, that means the water has a high velocity, and that means erosion would happen pretty quickly. Volume, which we've talked about, but volume, as the stream volume increases, it has to do with velocity, so the velocity is also going to increase. Okay, so these are things that are affecting how fast the stream is moving. And like we said up top, the faster the water moves, the more erosion will take place. Well, to get water to move fast, there has to be a steep gradient and there has to be a lot of water in the stream. Okay, I've got some graphs over here, but that does not make sense. Oh yeah, it does. Yeah, it does. Okay. Purple graph. So we have gradient at the bottom, and as the gradient increases, the velocity of the water will increase. Green graph, as the volume of the water increases, so more and more water is rushing through the stream, then the velocity of the stream is going to increase. Okay, so more water, stream moves faster, more erosion. Steeper stream, water moves faster, more erosion. This is important to write over here. What I've written over here in red is that if a stream is running straight, like if it's not going around any curve at all, the stream has the fastest velocity right in the center. So if we were to look at this stream right here and try to pick an area where it's not curving, maybe right here, it's going to be the fastest right in the center. And if you were to compare it to water that is way over here by the edge, or even way over here by the edge, that's going to be way slower. So fastest water in the middle. Now when we go around a curve, that's totally different, and I'm going to get to that. Okay. Here is a overhead view of a river. So if we were to see this on a map, this is what we'd be looking at. And I need you to remember the word meander. A meander is all of these really cool curves. Here's one, here's one, here's a big one, here's another meander, and here's another meander. The meanders are just the bends in the river. Okay, meander is a bend in the river. Okay. So here's a close-up of a stream. I'm looking at it from overhead, and I want you to put X's where the water is moving the fastest. So if we look at line A, this is at a straight part of the stream, so the velocity is going to be the fastest in the very center. Now, like I hinted at before, when you go around a curve or you go around a meander, it's not the same. If you look at line B, okay, so here's the outer part of the curve. This is the inner part of the curve. The fastest water would be over here on the outside. Now, if the fastest water is on the outer part of the curve, that means that's where most erosion is going to happen. So if I wanted to build a house, I'm probably not going to put it right there, because over time, this is going to erode away, and my house might fall in the river. Over here on line C, again, fastest velocity of the water is on the outer part of the curve. Probably not going to want to build my house over here, because eventually that whole area is going to get eroded away. Now, could I build my house here on the inner part of the curve? Yep. Water is nice and slow there. There's absolutely no chance that that's going to erode away. You might actually it might be going so slow there that it would deposit sediment, and you might have a little beach after a number of years. Okay, these are showing us some profiles of what it would look like underwater if you're looking at a side view of the river. So I'm putting an X in the middle of A because that's where it was straight and that's the fastest. I put an X over here on this side because that was the outside of the curve. And if you look, that's where most erosion is happening. So that's going to be really steep right there because all those sediments are getting pushed away. And then it's going to be really shallow on the slow side. So that's the nice side to kind of walk in and maybe go for a swim. And then on line C, again, here's the outer part of the curve. So I put my X over there, really shallow over here. If I'm going to build a house, I'd want to build it on the slow and shallow side because it will not erode away. All right, a couple sentences to finish it up today. At the outside of the curve, the stream velocity will increase. Therefore, erosion will increase. So on the outside, the stream is going really fast, and there's going to be a lot of erosion there. So that edge of the stream is eventually going to wear away. Now on the inside of the curve, the stream velocity is going to go slower, and therefore there is no erosion happening there. It's actually depositing sediments. It's actually going so slow that it's going to drop any sediments that it's carrying. So no fear of erosion on the inner part of a curve. Okay. Now if I go back to my original picture, back to this picture of Brad who bought a piece of land and a river runs through it and he wants to know what side of the river he should build his house on. Based on what we just talked about, which side of the river should he build his house? Should it be on the outer part of the river or on the inner part of the river? And I'm hoping you can even explain why. Okay, if I were Brad, I would want to build over here on side B. And my reasoning would be, because it's on the inside of the curve, the water is moving slower. And when the water moves slow, it doesn't erode away the sediment. So it will actually deposit sediment right here. If I were to build over here, I would probably be really in trouble in maybe 20 years down the road because this river is going to start to erode away the side of the riverbank. Okay, guys? Please message me with any questions, and I hope this helps.